In order to connect new clusters, click on the Connect New Cluster button. I'll click on Other over here, just copy this thing, come over here, paste, enter. And so a few things run. Now I click Go to Dashboard, and it says looking for new connections. In a few minutes, but technically it's about a minute, we'll see essentially a new row show up over here. Okay. Yeah, so now this cluster showed up here. Let's go to the workload analysis section. You'll see every single workload we have over here, k get pods dash a, the deployments, yada yada. These workloads here. That's all it takes. You can click on any one of these. Again, because we just literally just connected it, there's no data points. In a minute or two, we can start to see more and more stuff show up over here. And that's it. We see the Docker operators here. I'll just filter for essentially active workloads with name Docker. We look at this one, request 2 gigs, uses less than half of it. Again, analyzing this workload, we can see some changes are happening over time. And again, this is because different autoscalers are in place. So now I'm just looking at the Docker queue deployment. Let's pick a random policy, the conservative one. Great. Replicas goes down, CPU, memory, everything goes down a little bit. Let's look at the manual patch command though. So this is this bit rolling update. It'll just add a pod first and not remove all the pods at the same time. This is just to make sure the service is reasonably highly available. The second thing that we are, okay, so I applied that way. Now when I patch the deployment, everything won't break all at once. I've applied the deployment over there. Now you can essentially see the number of replicas have gone down, the number of requests. So now I'm going to do two things. Let me click on the optimize button over here. Let's go and pick balanced policy. Great. And then just attach the policy to this workload. So now the next time, DevZero will continue to monitor this workload all the time, right? And then it'll go and keep resizing it as and how it sees. And so very soon, we'll be able to see the impact of the automation kick in over here as well. So this is the value of automation, right? You don't need to go and change every single health chart everywhere. You just have computers based off of active utilization, keeping track of all of your workloads and just managing that to make sure they keep running while they don't cost a whole lot of money.
Okay, so tying everything that Debo presented so far to the bigger picture, which is the ultimate saving. So we can see here a list of clusters we connected. You can see the monthly cost of these clusters is a little over 100K, which is about $1.2 million a year. You can see the projected savings and what the actual cost is going to be after the optimization. So after the optimization, it's about $7.5K, which is roughly $90,000. So essentially reducing the cost of these three clusters from about 1.2 to roughly 90K, maybe 100K. You can see a drill down by CPU, by memory, by GPU, what is actually being used, what's been requested. You can see that over time. You can dive into each and every cluster, and you can see the potential saving for each and every cluster, down to the node and the workload. Two things that we didn't talk about in this video is live migration and bin packing, which is essentially optimizing the node configuration and reducing the amount of nodes. We can talk about that in an upcoming video. And then the second thing is we talked a lot about optimization, but not much about the visibility. And so beyond understanding which workloads are actually driving majority of the cost, you can actually also see that by departments. And so you can configure by department which workloads belong to which department, and understand which departments are driving most of the cost, and do things like chargeback. So really a good understanding of where your cloud cost is coming from.